going to be another live coding lecture. On Monday, actually, we covered everything that the state pattern actually is, and then Wednesday was more examples, more practice, more complicated lecture question. Today is the same thing. It's more reinforcing the state pattern. This is a tough topic. It also requires digesting previous topics in the course. This is a good time to take some time and just make sure everybody's up to speed, do a little bit of review. So today's lecture, live coding. But I'm going to at least attempt to do this. Leave it up to all of you as to what that live coding is. So if you have any ideas for a program, preferably that fits into the state pattern, something that has different behavior depending on its current state, let me know. Either raise your hand and shout it out, or preferably hit it in the Twitch chat. And if we get something that we can turn into a question, and I'll do the in before somebody says calculator, microwave, or car. None of those. I'm not doing that, obviously. But if there's something else, whatever it is, I'll try to do it without control flow. And of course, I'll be applying the state pattern wherever I can to give you more examples of the state pattern. If we don't get a good one, I have a default one, but I think it's really boring. It's just as the weather changes, and I don't know. I don't really like it. But that's what we'll default to if we don't have any other ideas. Breath of the Fire with multiple dragon transformations. Fortunately, I haven't played Breath of the Fire, so I'd have to get some more details. Yeah, the car state pattern. Thank you. I already mentioned that one. States of matter I want to do. I almost had a lecture question with H2O being water, water vapor, or ice. I just couldn't come up with the actual application. Like, what is it going to do differently in those states? If you can give me some specs, I'd like to do that one. If we can get some different behavior. I was going to have a person class who can consume H2O, and if it's water, they're refreshed. If it's ice, they get cold. But then what happens when it's water vapor? Does it just not do anything? I don't know. So if we can get some good specs, get some good behaviors defined, we might be able to do the states of matter. All right, so today's lecture question, which is why somebody already mentioned car as a suggestion. If cookie's eaten might be one we can work with. The car for the lecture question today. So, of course, a little more complicated than the previous two. We're just slowly increasing, so these lecture questions can prepare you for those homework assignments. But a car that can either be in park, drive, or reverse. So again, for the most part, the states are defined for you. The API is defined for you. Though, just a quick hint, you'll notice this as you start reading through the sheet, but you're going to need more than just those three states, unless perhaps you do something really clever that I haven't considered. But I think you should definitely have more than these three states to be able to complete this problem. So the car, when it's in park, it starts in park. It's initially not moving at all. And we want to be able to test this with the velocity. So when in our test package, in test car, you're checking the velocity, the current velocity of the car. That's the only means you have to test in the test car test suite. Again, you can test your implementation specific functionality in a separate test suite, but whatever's in test car needs to conform to that API. It'll create a new car and then call these methods in a bunch of crazy ways to test all the functionality. So the car starts in park, velocity is 0. You can shift into either drive or reverse. Drive, when you accelerate, it's going to increase the velocity by 10. Reverse is going to decrease it by 10, so you have negative velocity. So if I shift into reverse and accelerate twice, I'm going to be going negative 10 for my velocity. When you're in park, you can shift into either of the other two gears. When you're in drive, you can shift into park while you're stopped. And you can't shift into reverse regardless. Similar with reverse, you can never shift into drive from reverse. You can shift into park as long as you're not moving. And in either of these gears, drive or reverse, hitting brake, so calling the brake method, is going to reduce your velocity all the way to 0. So, for example, if you want to, so a typical usage of your car, You start, it's in park, you shift into drive, accelerate maybe 3 times, you're going 30. Hit the brakes to stop, you're going 0, and then you can shift back into park and then stop your car. You can shift into reverse at that point, accelerate a few times, start moving in reverse, hit brake, go 0 again, and then shift into park to stop the car. So any questions on this question itself? Yes?
Does brake just return that 0 at the end?
Brake doesn't return anything, so it will return unit, but it always set the velocity to 0. Yeah.
It doesn't like
No, it always set it to 0. If I had to decrease it by a certain amount, then we have to have something where we might have to use a conditional there. If brake and set to brake, reduce, if 0, then we're stopped and we can shift into park again. By setting it to 0 all the time, that's how I'm getting rid of that conditional. When you hit the brake, you're allowed to shift into park again no matter what the velocity was. Is the reason it's set up like that. So brake always sets the velocity to 0, all the way to 0, regardless of what the velocity is. The velocity could be 1,000,000. Brake, we're saying, okay, we want to fully stop this car, set to 0. And these, and we'll see what we get. I'll double check the Pokemon. I need more specifics though. Do Pokemon is pretty open-ended. I guess the evolutions we could do. We could do Pokemon evolutions. And we'll see. So we'll see what we get for today's live coding. But these lecture questions and the homeworks, they're very carefully crafted to make sure that you don't need a conditional at any point. It takes a while to generate these questions because I have to avoid any spot where you really need a conditional, or it'd be very, very difficult to not use a conditional. Like the TV volume, that one was a little kind of close, but I gave you the hint slide with the math.max and math.min to be able to get the max and min volumes. That was kind of a little close there, but there are a lot of places where but when you hit the max and min, notice that there was no state transition at those 2 points. That would have been too prohibitive. So these are very carefully crafted. So we'll see what we get if we can do this without using control flow. Uber Eats, that's interesting. I don't know if that'll fit the state pattern. I guess the order could be placed, being processed, being delivered, but maybe we could do that one. Jesse Mad to Jesse Laser to Jesse Zero. Top quality meme, by the way, that GIF. I'm liking the Pokemon. There's a lot we can work with the Pokemon. I might run with that one. So if people have more specifics with that one, I might run with the Pokemon one. That's a game I have played. Back in my day, we played that Pokemon Red and Blue, the originals. The cost for that. All right. So I just have 2 slides on the state pattern just to kind of wrap things up. But the state pattern, just to reiterate the pros and cons here. The pros, it helps us really organize our code. There are no, once we have our state pattern set up, there are no methods. There can be, but the methods themselves are much simpler to write. We have one particular state and what's the behavior for this particular API call in this particular state. Once everything's set up, those methods are easy to write. A lot of the methods that we saw in lecture were 1 or 2 lines. Even for my calculator and microwave, I don't think I went over 5 lines for any of my method calls. And even when I did hit 5 lines, it's because I was being a little sloppy with my code. I could certainly trim those down to be a few less lines. So it's very easy to have very complex behavior without any single method that's very difficult. Downside, we have a lot more classes. So if we have behavior that's not changing much, which if we had to default to my weather example, looks like we can work with Pokemon. We got this. But if we had to go to my weather example, I have 4 different states of weather and also 3 different coats that you could wear, either no coat, a raincoat, or a winter coat, and it could be raining, snowing, cold, or warm. So we have 4 states of the weather and 3 states of what outerwear the person is wearing. Well, this means we have to have 3 times 4, 12 separate states for all the different combinations that can happen. Is it snowing with no coat? Is it snowing with a raincoat? Is it snowing with a winter coat? Is it warm with a winter coat? Is it warm with a raincoat? The number of states can blow up like this. It can blow up exponentially depending on the different variables you have. We add to that, are you wearing rain boots, winter boots, or no boots? Well, now we have to multiply that by 3 again. And then maybe, are you wearing a hat or not? Now we got to multiply that number of states by 2 again. The number of states blows up incredibly, literally exponentially. Every time you have a new choice, even if it's a binary choice, that's 2 times the number of states. So if you have 10 binary choices, 10 either this is true or not, effectively 10 booleans, that's over 1,000 states that you have already. It's 1,024 states just for that. So prohibitive blow up if you're using a different state for every different set of behaviors. So if it's a strict no control flow, you get a lot of these states, a lot of duplicate states. We had rising and falling, and also rising and falling after a double jump. Well, if we had maybe a triple jump, if you could jump 3 times, 2 double jumps, it's just going to blow up even more. So it gets really, really gross at some point when you have all that complexity, all those classes. And at some point, of course, we would have some mix of the state pattern and control flow. You would never hold yourself to this in industry, this strict no control flow at all. So don't use control patterns everywhere. Yes, I'm forcing you to, but that's just because I want you to get exposure to this way of thinking, this way of using polymorphism in your homeworks. I am not saying the state pattern is what you have to do. Like, this isn't the next step, and this will kind of be a theme of the course. This isn't the next step of your programming experience. It's not like, okay, I can use functions, now I can use loops and conditionals, and this is just that next progression. You learn classes, and then you learn the state pattern. This is one option, this is one method, this is one approach that you can put in your toolbox. And when you have a problem where you have this complex behavior and behavior changing significantly depending on different states, that's when you can pull the state pattern out of your toolbox and apply the state pattern to that specifically. I'm definitely not saying that control flow is bad. I'm definitely not saying that the state pattern is the solution to everything with state. But this is one approach that you can use to help organize your code. And also, you might see it out there in industry. You might get there to your first job, and they might have the state pattern implemented. I want you to be able to see that. Or at the very least, they're going to have potentially, I guess not necessarily, a lot of polymorphism, a lot of inheritance. I need you to be able to read that, understand what that is. If you can understand the state pattern, I'd say you got polymorphism and inheritance down pretty well. That applies to this learning objective too. If you can do the state pattern like crazy, those first 2 bullet points on this one should flow automatically. Okay. Okay, I think we can, here's my weather one. I'm glad we don't have to do that one. So let's try to get at least a couple quick specs, and then I'll go right to the code, and we'll start coding. Not exactly what I'd recommend to dive right to the code, but hey, we only have half an hour here. So write a Pokemon class. The API, let's say, oh my goodness, can't do this. Let's say the API is get ball thrown at. Say ball thrown. So throwing a ball at the Pokemon. Damage the Pokemon. That's not part of the API though. The catch rate will be part of the states, but we will have a catch rate in there.
Would a Pokemon like battle be easier? Like if you're from a trainer, like a trainer's perspective.
Wait, what if you have a different class for battling a trainer and wild Pokemon?
Yeah, like
Yes. So initially, the Pokemon's going to be wild. Wild and full health. And we'll say base evolution. Say battling the Pokemon damages it, making it easier to catch. And just so we don't have infinite states based on the HP and everything, let's say, you know what? We don't have to say that. Let's just say makes it easier to catch. I think we can do that without control flow. No, we can't do that without control flow. So I think I'd have to pull in control flow if I do that. So if I do really any randomness, I have to do a random roll. I have to generate a random number and then say if this random number is less than something. So let's go with the pure no control flow and avoid that one. But let's say damaging twice guarantees a catch. Catching a Pokemon tames it. It can't be caught again. After being caught, it can't be caught again. After being caught, battle is a trainer battle, whatever that means to us, or it's a trainer Pokemon at that point. You might be battling another wild Pokemon, and let's say after caught, EV, whoa. And after being caught, it can evolve, feed, thunder? Leaf isn't a one, it's water. Water, fire, and thunder. All right, so let's, now that we got somewhat of a spec sheet, let's go to our code and try to code this thing. If we get all this functionality, then we'll go back to the drawing board and try to add some more features to this thing. All right, so let's rename this literal thing, refactor Eevee. That is spelled right? E-E-V-E? Okay. Okay. Eevee family. So the Eevee can be in some state, var state of type Eevee state equals new oh my goodness. I don't know why I can't type that one. This. So we have some initial state in our API. Which is ball thrown. Unit. this dot state dot ball thrown. Do some cut and paste in here. All right, and now what I like to do whenever I have a state pattern like this, the outside world's only going to interact with this EV family type Pokemon. So I'm going to create a separate sub package for the states, just to kind of keep that out of the way of my public facing interface. Then I'm going to create my states. I just named that state, I believe, right? Did I name it EV state? Yeah, I did name it EV state. Whoa, 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 whoa. If you're wondering what I'm doing here, like why don't I just do EV state like this? If I do if I do refactor and rename, that's going to also rename my file. And if I want to change something that's used all across my code base, that's going to change every instance of that if I do a refactor, instead of trying to chase through every place where I use that name and update it all. Oh, my clipboard. No, and I copied it instead of, I cut it instead of copying it. Oh man, ruined the state of my clipboard. All right, so let's get rid of these. E, B, family. Oh, because I don't have a variable name. All right, so we have our state set up with our state API. The API, we kind of just made it up, but we have our state API of the ways that we can interact with this EV, and each one of those we're going to defer to the state because these methods are going to have different behavior depending on the current state that we're in. So let's create our initial state. This, I'll mark it abstract, even though I do have concrete definitions for all these, but I will mark this abstract, just because we shouldn't ever be in the base EV state. So let's create wild EV with too many E's. Extends EV state. All right, and now, whoa, what are we doing? Okay, now at this point we should be able to get rid of all this red. Not like that. Not like that. And all the red's gone. So we have our base set up here. And what I was doing was adding the imports. I'm doing option click, and that's going to look for a class with that name to import. So we have our EV, starts as a wild EV, and is deferring all of its state, all of the functionality to its state. So let's start looking through our states and figuring out what kind of states this EV can be in. This was the next step. Okay, what are the different states that I can be in that are going to change behavior? So the wild EV, of course. I also want trainer EV for after I catch it, after a trainer catches it. Trainer Flareon. Trainer Porion. I might spell some of these wrong. And trainer Waterfire Thunder Jolteon. All right. And at that point, we're going to start in our initial class. That's usually where I like to start. Start in the initial class and start overriding the behavior based on what we're seeing. So I have, and I'm going to need more states than this, but we'll step through the process and see where we're going to need more states. So if I have a wild Eevee, and I have a ball thrown at him, or her. Let's say, so we can have the probability, we would have a very low capture rate at this point. We didn't damage it at all. But instead of having that capture rate here, where we would have to have a conditional, let's just say there's no chance of being captured here. So, no capture. You have to damage it first. So of course, let's battle it. And let's say after, we said after battling it twice, we're guaranteed to capture it. So let's say, since we don't want to say if damaged twice, if number of times damaged equals 2, when we're strictly going all in on the state pattern, that's got to be 2 different states. So once we damage it once, it's going to have different behavior because when it's damaged again, it's just going to move into a different state. So the behavior itself isn't necessarily different, but we have a different state transition that we're going to see. So if it's damaged once, we're going to say this dot Eevee dot state equals new damaged once this dot Eevee. So we're going to transition that state to being damaged once and saying, okay, we're a little bit closer to being able to capture this thing. Damaged once, you have to damage it again. Damaged. Let me do a little cut and paste here. And then transition into the damaged twice. Well, the EV damaged 2. Well, I'll stick with it. Actually, no, I'll show off the, so it's damage 2, the file name, the class name. Anywhere where we use that, I'll show off refactor since I mentioned it earlier. Oh my goodness. Refactor, rename, damage twice. That's going to change the file name, any usage, the class name, everywhere where that appears, where that was used, that name changed everywhere. So now, I mean, we might as well add fainted here. If we damage it again, oops. This dot ev dot state equals new fainted this dot ev. Oh, come on. Then fainted, just no functionality. We'll say that, we could add a Pokemon Center method in here. Let's not go that far. Let's get the functionality that we have defined already. So battle is going to change to fainted. Not too interesting. But damage twice, throw a ball. You caught an EV. And now this is going to turn into a trainer EV. And let's see, are we missing anything? Yeah, feeding the stones won't do anything when it's a wild Pokemon. But once we have a trainer EV, we'll ignore levels for the sake of time. But we'll say once you have a trainer EV, or actually, no, levels don't matter in this one. What am I thinking? But we can start evolving this EV. Feed waterstone, this dot EV dot state equals new trainer Orion. That looks like it's spelled wrong, but I can't think of it right now. It's not critical to the state pattern, so trainer Flareon. Did I not? Yeah. Oh, wild Jolteon. Good call. Gotcha. So let's get in here. Refactor. Trainer Jolteon. And we'll just override these to print. We won't be able to build too much functionality here, but we'll print using fire attacks. You can imagine the type of functionality we would want to build here using thunder attacks. Using water attacks. And despite what I recommend, I'm writing my test after my functionality, not recommended. But let's test this and make sure that does what we expect it to do. So I think it all seems all right. I'll stand here and claim that I built all that functionality just right. But let's check. Let's test this. Let's not take my word for it. Let's see how we're going to interact with this EV class. So let's start EV family equals new EV family. So we get our new EV. And we can call these API methods. Let's throw a ball at it. Battle it. I have this in a test suite, but I don't have anything that I can actually test. I'm just printing to the screen, so I won't be able to have any asserts here. But we will be able to see what's happening with this test. So throw a ball. Let's do that again. So we're going to throw a ball, that shouldn't do anything. Battle it, throw a ball, that shouldn't do anything. Battle it, it's damaged twice, throw a ball, and now we've captured this EV. EV.battle. Now battle is going to have this EV fight for us instead of us fighting against this EV. So EV.battle. And the big choice. Jolteon. EV.battle. So we're of course going to get our green check marks because I'm not actually testing anything. There's no asserts. But I want to check the the council output. And we can kind of trace through, this isn't proper testing, but we can kind of trace through where, what happened each time. So ball thrown, you have to damage it first, battle it, now it's damaged. Ball thrown, you have to damage it again, damaged. Ball thrown, we caught an EV. Using, I did print instead of print line. Battle it, EV's using its normal attack. Feed a Thunderstone, we have a Jolteon, battle, now we're using Thunder attacks. So we were successfully moving through those states, and then we can start adding new functionality to this thing. Let's see if we got something in chat. There's definitely something going on in chat. not quite new functionality for us to add though. Let's change these to the print lines that they should be. Rerun our tests. And we get that functionality. What else do we want to add to this? So my big pitch is that the state kind of makes it easy to expand and add new functionality. What's the next thing that we would want to add to this? Yeah, I'm only really familiar with the Gen 1, so I know there's no evolutions, but sorry.
Another evolution.
Yeah, another evolution. Oh yeah, I didn't realize that's what you were saying. All right, you're really gonna push my knowledge though. I don't know much past Gen 1. So wild EVs can't evolve. Trainer EV can evolve, but we got to add this to our. Well, I did have the leaf stone earlier. That is like Leafeon. I think that's one of the new ones, right? Yeah, let's do that one. Someone's gonna have to refresh me on the evolve night and evolve day. It's Umbreon. In a happiness setting. And whoa, slow down there. That just told you how states explode exponentially. We don't need all that. I'll do the day and night though. How do you trigger the Umbreon and? Oh, I do need the happiness. Let's just say make happy, not do that as state. Make happy. For some reason I did a capital M there. Change to day. Change to night. All right, I gotta think about this one a little bit. So make happy in trainer EV. So we'll say that just making them happy is going to trigger the evolution. And I want to say if day, I know I can't do this, I'm just saying this is what I would want to do. If daytime Umbreon else Espion? Is that spelled right? E-O-N? Oh, obviously E-O-N. Thank you. All right, so this is the logic that I want. Is that backwards?
Yeah.
So this is the logic that I want. So how do we get there? How do we get there? So we want a different state. And this is where we can potentially see the number of states really blow up. Trainer EV, daytime, and yeah, this is where we start to see the shortcomings of the shortfalls of the state pattern. In trainee EV, nighttime. So we need two different trainer EVs. I'm going to do 3 of them. In fact. So I'm going to have a trainer EV as an abstract class. Missed my polymorphism, my inheritance there. Trainer EV is going to have all this functionality except make happy. These are going to extend trainer EV. And if we're in the daytime, we're going to change into Umbreon or Espeon. Say, okay. I am missing my spelling on that one. Dark. So if we're evolving in the daytime, this .ev.state equals new trainer Espeon, this .ev. Evolve in the nighttime. All this logic is gone because we're inheriting it from trainer EV. And we're moving into a trainer Umbreon. Yeah. And we have 2 new methods that we have to implement, change to day and change to night. It's going to get tricky. We might not be able to fully implement this one, but at least explain what the rest is that we would have to do. Override. Change to date is going to be this .ev.state equals new. Change to daytime, it's .ev. Whether it's nighttime or daytime, if we call change to night, change to day. So if we call change to day several times in a row, we'll just keep staying in this state. And change to nighttime. And we have one last thing. So this is where we would see the big blow up in the number of states. This is a wild EV. We still have to keep track of whether it's daytime or nighttime. Now normally we would just store that in a Boolean and use a conditional. But here we have 3 different states that the EV can be in while it's wild, and it has to remember how much it's been damaged and whether it's caught or not, if it has been caught. But also remember whether it's daytime or nighttime. This is where we start to see the big downside of this pattern, is we have to have daytime and nighttime for each of these 3 states as well to track the daytime or nighttime. We can't just transition into trainer EV daytime or trainer EV nighttime, Because if it's a wild Pokemon that's been damaged once, well, we have to remember that it's a wild Pokemon that's been damaged once. If we're doing that strictly through states, that's 3 more states down here for daytime and nighttime. And if I'm using inheritance, that's 6 more classes just to keep track of daytime and nighttime. So this is a case where you would not strictly apply the state pattern because, I mean, look at how many states we have already. I mean, some of these you're going to want, each one of these, each evolution, you're going to want a separate state, but not all these things. So let's go to our tests. We're not going to feed a Thunderstone anymore. EV dot. Oh. I'm going to cheat a little bit here, just because we only have a minute left. Change to night. EV dot state dot make happy. I had to cheat a little bit. I added those new methods to the state, but I never went back to the base EV class to add those and say when this method's called, defer to the state. I'm cheating a little bit. I'm just accessing the state directly. That's not something you would normally do. Don't do what I do. But when we change to night and then make happy, we're going to start getting our dark attacks. So we've successfully evolved into an Umbreon in that case. All right, any quick questions on this? Yes.
Can you add WebSockets?
Right now?
Yeah.
No.
2 minutes.
There are 0 minutes according to my clock. Oh, 2 minutes? Yeah, let's add WebSockets. The display on the room thing says 150. I've been looking at that. Since there is a little bit of time, let me fix this one instead. No, I can't add WebSockets that quickly. Sure, I'd like to. This dot state dot change to day. This dot state dot change to night. So to summarize the state pattern, and make happy. I just didn't cut up to here. Just to summarize, the state pattern, every time we have a different set of functionality, so even if one method does something different, or even if a state transition is different, we need a new state for that. So when you're thinking of your calculator or microwave, every time you're in a different state where any of the functionality is different, whether it's a state transition, whether it's a tiny bit of functionality on one button, that's going to be another state that you have to write. Since we can't use those conditions, we can't have any code executing conditionally, it's always going to be a new state. But again, the homeworks were designed so the blow up in states isn't ridiculous. You're not going to face these situations where you would need like 4 more states in a particular situation. All right, with that, let me look at this clock. Oh, 2:08 now. With that, have a good weekend. I'll see you Monday.